Here's another system of equations involving three equations with three unknowns. In order to solve a system of equations, you must eliminate the variables, clear them out so that you know what the values are. So if I choose to make my y's go away, and I made that choice because I had a minus y and a plus y, and the x's would have been easy to make go away, the z's would have been a lot more complicated. But I'm going to use this equation 1 and equation 3 to eliminate my y. So when I add those two equations together, I get 3x plus 9z equals 12. Now I also need to make sure that I use equation 2 in this problem. Each equation must be used in order to solve the system. Since that has a negative 2y with it, I think I'll use equation 3 and multiply that equation by 2. So equation 2 and 2 times equation 3. So when I add these two equations together, I get 3x, the y's go away, plus 11z is equal to 14. And this is what I call equation 5. I forgot to label this one. This is what we call equation 4. So we take equation 4 and equation 5 and decide again which variable we want to get rid of. We already got rid of all the y's, which was what our first intention. Now we have to get rid of another variable. It appears that it would be easier to get rid of our x here. If I multiply everything in this first equation by a negative 1, then I would have negative 3x minus 9z equals negative 12, and equation 5 hasn't changed. 3x plus 11z equals 14. Let's add these two equations together. Our x's go away, and we have 2z is equal to 2. So we can see that z equals 1. Now we need to go back and find what x is. In order to do that, we use either equation 4 or equation 5. Let's use equation 5. So we replace z with 1, and we get 3x plus 11 equals 14. 3x equals 3, and x equals 1. So here I subtracted 11 from both sides, and here I divided by 3 on both sides. Now I still need to know what y is. And therefore I go back to one of the original equations. Let's go back to equation 3. So in equation 3 we put down that x is 1 and z is 1. And if we work out the math, that would be 4 plus 1 more is 5, from 7 is 2. We get the y equals 2. So it appears that our answer for this problem would be the ordered triplet, with the x value being 1, the y value being 2, and the z value being 1. But this is not the correct answer if it doesn't work in all equations. We found it by using equation 3, so it checks in that one. Let's check to see if it works in equation 2 and equation 1. So in equation 1, working that down here, I'm running out of space. 2 times 1 minus 2 is 0, plus 5 times 1, which is 5, is equal to 5. That checks. We also need to check it in equation 2. 1 minus 2 times 2 is negative 3, plus positive 3 equals 0. That also checks. So this is indeed the answer to the system of equations.